Hi everyone, it's me again. Um, I hope you're doing fine and you stay healthy. Now we have the solution for the comparison exercise. I ask you to compare some data on considering the variation on the effective number of parties, and I asked you to find the suspects. What would be the causes of the variation in the effective number of parties? Um, this example of comparison is based on one of the laws of political science laws, the Duverger's laws. Duverger's law says that um, majoritarian electoral system, or the first past the post electoral system, they produced bipartisanism, while proportional representation, it produces multi-party systems. So what I wanted you to do is to understand this logic through inductive thinking, through analyzing the data and through the empirical analysis of the data. Most of you that delivered the exercise understood this and found that the electoral system was the one responsible for the variation. And I included another variables to confound you, to make more difficult the analysis. Why did I do that? I did this because in real life situations we have data that is messy with most things that we don't know. We are not sure about its relationship to what we are trying to explain. So the idea of this exercise was to teach you how to create, or how to find the effective um, cause for one particular phenomenon. In this case, the influence of the electoral system on the effective number of parties. Let's go step by step. Some of you has made the most obvious things to do. That's just to sort the number of the effective number of parties and see what was related to this. You did this in a very intuitive way, and most of you have doing it right. You made the exercise well. So we can see here that the most of the systems with 2.5 parties or less, most of them are first past the post system, and most of them are also Anglo-Saxon, are colonies, former colonies, or the United Kingdom itself. There's just one exception here, that is Japan. Okay, that is, they have 2.48 parties, and it's a mixed system, in part majoritarian and in part proportional representation. All other countries, they have the higher number of the effective number of party, higher number of effective number of party, and they are mostly in proportional representation. How do we understand this? We have, how do we make sure that we are not making a wrong inference? We are just assuming that is valid. First, you look into the theory. If you have looked into political system theory, you would have found Duverger's text that states political parties, that he states this law that majoritarian rule produces with just one round, it produces bipartisanism, while proportional representation or majoritarian rule with second round, with runoff elections, they produced multipartyism. So the first is the theory. Most theories, they help us to establish causal relations, but there are other ways of finding these relations empirically. I will show you some of them. The first one is I don't know yet what's happening. The first thing I'll do is I'll run a correlation among the most important quantitative measures of my data set. So I'm just asking here the correlations between the effective number of parties here and the other three variables that are quantitative: GDP per capita, HDI, Human Development Indicator, and the Gini coefficient of inequality. As we can see here, there's almost no effect of GDP per capita on the effective number of parties. The effect of HDI on the effective number is very low, almost insignificant, and the Gini is moderate, a little bit low, but moderate effect on the effective number. So the more unequal, the more unequal, the lower the no the sorry the more equal, the higher the effective number of parties. So we can see here this relationship between effective number of party and the Gini coefficient. So we have here this group and this extreme case with ENP above 15. The only case is Brazil. We have Brazil here. It's an extreme outlier. So let's take Brazil out and see what happens. I plot again without Brazil, and we see that we have a negative relation. The higher the inequality, the lower the effective number of party. And I'll do the correlation now without Brazil, and I find that the relationship increases from 0.362 to 0.555 if we round the numbers. So we can see that Gini is negatively correlated with the NIP. The lower the effective number of parties, the higher the Gini. So we will test this, and it seems that there is a relationship between Gini and the effective number of parties. But how do we test qualitative variables? How do we test for electoral systems, or if a country is Anglo-Saxon or not? For this, we can create dummy variable. A dummy variable is a variable that states that it's true or false, or 1 or 0. For example, here I create a variable in our data set called PR, for proportional representation, and it defines that if the electoral system is equal to PR, it assigns a value of 1, and if it's not PR, proportional representation, it assigns a value of 0. So let's create this and go back to our data set here. Oh, I need to refresh this. Okay, now we can see that if it's not PR, it's 0. So most here, if it's PR, is 1. So I divided into two groups: those countries that have proportional representation and those that have not proportional representation. And then I can use a test, a hypothesis test. There is this test called t-test, student test, that can test the difference in means. So the question here is, do proportional representation countries present higher effective number of parties when compared to other systems? And here I test both with 95% of confidence, with of 95 countries, how many really have higher of 100 countries, each group of 100 countries that have PR systems, how many of them have at least 95 countries that the effective number of parties in PR systems are higher than other kinds of electoral systems. So this is the probability of the PR having higher mean or average number of parties compared to other systems. Here it's 99. This is an uncertainty measurement. If I am really, really tough with my requirements, okay, I don't accept 5% of uncertainty. I just accept 1% of uncertainty. I want to be sure that PR have higher number of parties than other systems. So let's test the first one with 95%. With nine here, if you look at the statistics, we see that the mean of those countries with other types of electoral systems, be it the first past the post or mixed of two rounds, they have a mean of 2.7 parties is the mean of their effective number of parties, while in proportional representation it would be 7.5. This is huge, isn't it? It's three, there is almost three the difference in terms of number of parties. And the good thing about this is that this test give us the confidence interval. The confidence interval is if I repeat the test many times, in 95% of the cases I repeat these tests, the mean of the difference, this one minus this one, would be between minus 5.67 and minus 0.3. So it would be between 0.3 parties and 5.7 parties. So it would be a huge difference. It can vary a lot, but it's always negative. It's always negative. So it's always lower the mean in group 0, all other electoral systems, than the mean in group 1, this proportional representation. So always, if I use a confidence level of not 95%, always other countries that have other systems, other electoral systems, have lower average in terms of effective number of party. But what happens when I increase the level of requirement, when I doubt a little bit more? So I test always again, but with a little bit higher. Instead of 95% of accuracy, I want 99%. So what happens here? The means are the same because they stay the same. But when we try to understand the difference between the means, you can see that can be both negative. The mean in group 0 in those countries without proportional representation can be both lower and, this is the most important number, higher than the mean in proportional representation. So if I use a 99 confidence intervals to analyze this data, I cannot state for sure that the effective number of parties in proportional representation is higher than all other electoral systems. So not the proportional representation, it's not the best variable to measure. Let's do the same, but now instead of using proportional representation, let's use the first past the post system. I not will compare proportional representation to all other. Now I will compare just the first past the post with all other electoral systems. So I create the same variable here, another variable for the first past the post. You have here, if it's FPTP, it appears as 1. If it's not, it appears as 0, okay? We have all the cases here. So, and I repeat the same tests with 95% of confidence. I can see that the mean of the first past the post are 2.2 parties, while in all other groups, all other electoral systems is 5.3 if we round it, and the 95% confidence is between the group 0 is between 0. It's 1 and 5 parties higher than the first past the post. So the mean is with 95% confidence. If I repeat with 99, it's stay higher. It's from 0.17 to 6 parties. So I can tell for sure that the first part past the post have lower number of parties than all other electoral systems. So having the first past the posts decreases the number of parties, the effective number of parties. And this is with a confidence of 99%. We can also try something else, try to be more exquisite in our, and I want in 99.9% of cases what happens, and then I'm not sure anymore. But this is really a difficult situation. It's very you need to have a lot of cases in order to be this to be true. We have just 20 cases, so 99% of cases is a really nice confidence level. We can be very sure about this. But we have also another variable called Anglo-Saxon countries. So some countries are former British countries or British colonies, or they are the United Kingdom itself. So what if it's not the electoral system, but the common cultural background, the things that really matter to explain the effective number of parties? One explanation would be the institutions, the type of electoral system, the laws that regulate how elections are held affects the number of parties in contest. This is the electoral system explanation. Another potential explanation is due to their common or shared cultural background, they have the same way of running elections, and this make them vote just for 2 parties and not many more. So we can test the same assumptions for the historical or cultural variable. So I create the same dummy for Anglo-Saxon. So where is yes, it appears 1. Where is no, it appears 0. So the same thing as the former variables. So with 95% of confidence, I see that the mean for Anglo-Saxon country is 2.2 parties, and for all other countries that are not Anglo-Saxon, this is 5 parties, the average effective number of party. So, and the interval is also above 0, so they really have lower rates than the other countries. If I increase the level of accuracy, it stays above 0. It does not crosses. The problem is not being all negative or all positive. The problem is that when one is positive and the other is negative, or one is negative and the other is positive. If you have different signs here, you don't have the hypothesis of they are equal, it's confirmed. So since they are both positives, the hypothesis is that the true difference mean is not equal to zero, um, is equal to zero, is not confirmed, because I am really sure with 99% of confidence that the true differences mean between Anglo-Saxon countries and all other countries is above zero, is different than zero. They are different, really different. So, wow, I have a problem. I have a Houston now. What is the real cause? I have, on the one hand, I have the FPTP, the first past the post, that is significant, and I have also the Anglo-Saxon variable to help me, and they both are significant. They both explain. But what would be the one that is can explain best the phenomenon? So one way, and remember, we already had the Gini coefficient that was negatively associated with the effective number of parties. So the way of checking all this potential explanation is putting them all in a regression analysis. So the first thing I will do is I'll create a OLS regression with regression analysis with the effective number of parties with as the dependent variable, and the explanatory variable or variables or independent variables, the variables that I assume that have an impact on the effective number of parties, I put them as independent variables. So the Gini, we thought that it was negatively associated with the NAP, the Anglo-Saxon, and the FTP. What is the things that we are expecting? We are expecting that the higher the Gini, the lower the ENP. That if the country is Anglo-Saxon, the lower the ENP, and if the electoral system is first past the post, the lower the ENP. Okay, so let's run this regression analysis. So what we have here is the coefficient of the regression. We can see that no variable is significant. What this is telling us is, so just the Gini at 10%, at 90% of confidence. So the idea is that, as expected, the higher the ENP, the lower. If you have an Anglo-Saxon country, it decreases the number of parties, as well the first past the post. This is correct. The Gini coefficient is not working well. The problem is these two variables always they are measuring the same. If we look here, when we have first past the post, we almost always have Anglo-Saxon countries. They are almost the same, except for Taiwan, that is first past the post, but is not an Anglo-Saxon country. So in regression analysis, this could be causing when a problem in the estimation of the effects, inflating the variation, increasing the variance, increasing the effects of these variables. So we should test each one separately. So I will control the NIP here by Gini and Anglo-Saxon data. And after, I will control by first past the post. So when I take off the first past the post from the equation, you can see that at 95%, we see that the Anglo-Saxon is significant. So yes, this is a cause that we can attribute. So being an Anglo-Saxon country decreases by an average of 3.7 parties in the effective number of parties of the countries observed. So we are estimating that the effect of being Anglo-Saxon decreases around 3.7 parties just for being Anglo-Saxon. And this is statistically significant at 95%, okay, of confidence. Like, it's the same as the t-test, but here it makes the test for all variables. The Gini is not significant because it's just 90%. We used as a reference in social sciences 95% of confidence as the threshold for accepting or not accepting a null hypothesis. In the case, the null hypothesis would be Gini does not make any does not impact on the effective number. So if it's below 95, so I accept the null hypothesis that the Gini have no effect. But the Anglo-Saxon, it's above 95, so I accept that Anglo-Saxon countries have an effect on the effective number. So for make it more simple for you, if you have 1, 2, or 3 stars here, 3 asterisks, it's fine. It's working. If it's a point or nothing, it's basically when you read a regression, it's because it does not affect your dependent variable. Okay, so another important thing to look at is the multiple r squared. The r squared is the same number when you do the scatter plot. You remember when you do the scatter plot, when in Excel it appears an r with a square, 2 point, and the number is the same thing. This is the coefficient of determination. Basically, this coefficient tells us how much of the variance, of the variation within the dependent variable is explained by this model, by these 2 other variables. In this case is 0.289, 28.9% of the variation is explained by this model, the Gini and the Anglo-Saxon countries. So let's change from Anglo-Saxon to first past the post electoral systems, and let's see what changes. Again, here we have a similar result. The Gini keeps with no effect whatsoever, significant effect, and the first past the post also have a very similar effect than the Anglo, and it's also significant. The difference here is that the first past the post adjusts better to the problem than the Anglo-Saxon countries. Why is that? Because we have, for example, Japan and Taiwan here. Taiwan in particular. We have Taiwan that is not Anglo-Saxon, but it's bipartisan and have first past the post. So the best explanation will be first past the post than Anglo, because not all Anglo-Saxon countries have not all cases of bipartisans are Anglo-Saxon, but almost all are first past the post. Okay, so this is a very a quantitative way of understanding causality. So I find that the real cause is the electoral system, and particularly the majoritarian rule. The majoritarian rule that says that the first past the post systems, they produced bipartisanism. They drastically reduce the number of parties in the system. So we find that through these exercises how the electoral law, the Duverger law, is confirmed in the data. You see that if you have a type of electoral systems, you end up having less parties than when compared to other electoral systems. There is another way of doing this. This was the statistical way of being sure that this was the cause. But there is another way, is using a more qualitative comparative analysis. It's a method called QCA. QCA uses binary and fuzzy logic to compare cases and to understand what are the necessary and sufficient conditions for the production of a given event or effect. So I just uploaded in Studium a video on necessary and sufficient conditions. You should watch this. It's 5 minutes. Um, is very well explained. So you should look at this and learn what is necessary in sufficient conditions. But I just tell you briefly right now. Necessary condition is something that you need for something to happen. For example, you need to know how to read to go to a university. But knowing how to read is not a sufficient condition for you to have a degree. You can know how to read, but you need to make exams, study, and acquire a lot of knowledge and approve exams before you get a degree. So knowing how to read is a necessary condition, but not a sufficient condition to have a degree. Okay, so this is the way we think about causality. We can think about causality, think about if some condition is sufficient or is necessary for something to happen. So what we will test here is if Gini and the type of electoral systems, and if the country is or is not Anglo-Saxon, if these conditions are necessary or sufficient for producing the bipartisanism. So I will create a new data set with a variable bipartisanism. And all those countries with 2.5 effective numbers or less, they are considered as bipartisan, while all others are considered multipartisan. Okay, so I'll test this and see what are the conditions that are related to bipartisanism. The first thing is to just separate the data. I would separate bipart is my dependent variable here, and I select the three variables that we looked at before. Gini, if the Gini is higher than the median of our sample, if the electoral system is the first past the post, and if the country is Anglo-Saxon. We see that we have Gini, countries with higher Gini, both in bipartisans, that both have bipartisanism, and high Gini in countries that are not bipartisan. So Gini is not a great candidate for a cause of bipartisanism because it's present both in countries with bipartisanism and countries without it, with high levels of electoral fragmentation. What happens with the first past the post? First past the post, we see that most of all countries with first past the posts are bipartisan because you don't have any first past the post that are not bipartisan. The same happens with Anglo-Saxon countries. So we can exclude Gini because it's always present both in bipartisan and another countries. And these one are present always in bipartisan, and they are absent in other multi-partisan countries. So we need to check this. When we can check this using some algorithms from QCA, and it gives us the proportion of cases where you have that all cases that are Anglo-Saxon and are first past the post, they are included with bipartisan. And in the case of first past the post, 85.7% of the cases of first past the of bipartisans are first past the post, and 71.5% of all bipartisan countries are Anglo-Saxon. So the best candidate would be first past the post. We can use another algorithm that minimize the causal paths, the alternatives that can explain the phenomenon. And we can have here that all these countries here, Taiwan, Canada, Belize, United States, India, and United Kingdom, the best explanation is first past the post because the coverage, the covariance is 85.7% of cases of bipartisan cases are first past the post. So the software gives us this as the solution, the most probable cause for bipartisanism. So this is another way of using data or using logic to solve the problem. Look what happens at the same time and what is present and not present true. When this happens, this happens. When this not happens, this not happens. So you can tell if more surely that these two factors associated, but this one is the one that is most associated with the production of bipartisanism. So this is it for now. I hope I explained because there are a lot of statistical things here, new things here, but the idea is try to exclude alternatives, try to find what is the best explanation for a phenomenon, and both using logic, like here, we just put everything as zeros and ones, and watch and see what is present and what is absent, and using statistics to funnel down causes and variables, separate variables that are not important, eliminate them, and focus on only those suspects, those variables